Hello, everyone. This is Adrian Howard, Weather Rampage's Winter Outlook 2016-2017. It is now out right now, and I'm going to be showing you some things this year as far as this winter, as winter is now approaching very quickly. I know everybody has gotten their winter outlook out, but I am the one that is slow on this winter outlook, but I think it's good timing for right now. But I kind of wanted to show you because we're heading into that pattern of La Nina or neutral phase, and it's kind of fluctuating, and I kind of want to show you what's going on. But first, I want to show you what El Nino and La Nina is. It is a typical weather pattern that happens for around the well, actually here in the northern and the North American states. It's typical weather pattern, and for the typical wintertime pattern, La Nina, as you can see, the polar jet stream here is usually off the Alaskan coast, and it moves in this general direction here into the northern United States and exits off into New England. And wet and cool conditions prevail here in the Pacific Northwest. Very wet conditions with the Pacific jet stream. High pressure is located here, and also dry and warm conditions prevail in the south, and wet conditions here in the Great Lakes regions. And anywhere in between there usually is average as far as temperatures and as far as how wet it is. Now, for a typical El Nino pattern, weather pattern, low pressure stations itself off the Pacific Northwest coast. Warm air usually is on the northern edge from Alaska all the way into Canada, into the northern tier states of the United States. Dry conditions prevail here in the Great Lakes regions, and a persistent extended Pacific jet stream and amplified storm track is usually here along the southern states, and wet and cool conditions prevail usually from Southern California over into areas of Oklahoma, all the way over in Texas, over into Florida and the Carolinas. And in between there, average conditions prevail usually. And the polar jet stream usually stays up here into Canada, northern Canada. And as far as what the waters look like on a map, on a sea surface color map, as you can see for El Nino, the waters are usually white and red and orange here, indicating a El Nino, which is a warming of the ocean waters. The sea surface temperature anomalies warm up. And November 1997 is what it looked like here. This is what it looked like, the ocean waters for El Nino. Now for February 1999, as you can see, the colors here are purples and blues, which indicates that the waters were cooling. The sea surface temperature anomalies were cooling, which indicates a La Nina sea surface temperature phase pattern. I just kind of want to show you that. And as far as this year for the CDAS sea surface temperature map, courtesy of tropicaltidbits.com, as of December the 2nd, 2016, these greens represent the waters cooling, and these reds represent the oceans warming. As you can see here off the South American coast, west coast, the waters are cooling here. They're getting cooler. They were reds and oranges. Now they're starting to turn into greens, which means that the waters are cooling. The lower the temperatures, the darker, well, actually, yes, the lower the temperatures, the darker the colors, and the greens indicates darker coloring. So it is getting colder. The waters are getting colder. And as you can see here, courtesy of Tropical Tidbits, the CDAS sea surface temperature anomaly difference for global mean SSTA and Celsius, degrees Celsius. As you can see here, the temperatures are getting colder because there's a lot of blues here and along these ripples or these waves here off the South American coast, which indicates that a La Nina is developing. So the waters are cooling instead of warming. Last year the waters were warming. We had almost a Godzilla of an El Nino in the sea surface temperature anomalies. Now the sea surface temperature anomalies are going more cold now. So I just kind of want to show you that, and that is going to affect the weather pattern here in the U.S. at some point. As you can see here, courtesy of the National Weather Service, same thing. Waters are getting colder, indicative of the blue areas here off the South American coastline, western coastline. Now, as far as what I expect, because of this La Nina phase or the neutral phase pattern of the waters here for 2016-2017 precipitation predictions, I expect it to be way wetter than average here in the Pacific Northwest, more wetter than average here outside of that here in areas of Montana and Oregon, and south of that here in southern Oregon, southern Idaho, up into North Dakota, and South Dakota, up into the Great Lakes regions, I expect it to be wetter than average. And here for the Great Lakes regions, I expect it to be more wetter than average, or more wet than average, excuse me. And in the center of the nation, from California, Nevada, into the center of the nation, which is the Central Plain states, into the Carolinas, areas of the Carolinas, and New England, and the Mid-Atlantic states, I expect the precipitation to be average. South of that, here in almost Southern California into northern Arizona, northern Nevada, the Panhandle of Texas, and central Oklahoma, which includes Oklahoma City, up into areas of Atlanta, Georgia, Alabama, Mississippi, and South Carolina, southern North Carolina, I expect it to be drier than average. And south of that, more dry than average, and way drier than average here along the Gulf Coast states. So this is what I'm expecting. Doesn't mean it's going to play out. It's going to depend on a lot of factors, and I'm going to get into that in just a minute. And as far as the temperature predictions, here in the deep reds, I expect here to be way above average here in southern Texas, Arizona, and New Mexico. More above average here in Oklahoma and Texas, and areas of California and Florida. Above average here in this almost the central states, kind of the central states, up into areas of, let's see, Northern California, and also air over here to areas of the Carolinas and Virginia. An average north of that, below average north of that, and more below average north of that, as I think more Clipper type systems or more shots of cold air will be able to plague the northern tier states in this weather pattern. So that's kind of what I wanted to show you. Now, as far as the weak polar vortex characteristics, I want to show you, because the polar vortex a lot of times has a lot to do with our weather patterns. And when there is an above average geopotential heights, they're above average geopotential heights, they're associated with the weak polar vortex. And as you can see here, these reds indicate a weak polar vortex. And what happens is, the higher the pressure is up here on the North Poles, or the North Pole, the atmospheric pressure over the Arctic leads to a weaker westerly winds in the upper atmosphere. And because of these weak westerly winds, more cold air usually is funneled into the United States because of this strong Azores high pressure that develops. And because of the westerlies being so weak, that allows the air to be able to buckle more and to move more into the U.S. as opposed of the westerlies kicking out all of this cold air out of the U.S. and having it back pushed back into the North Poles. And that's a lot of times that's what happens. Now, this is not in a, well, actually it is a polar vortex, because a low pressure system develops with the Azores high, but it's a weak polar vortex. So with the weak polar vortex in place, a lot of times that cold air is allowed to buckle to come more into the U.S. So I just kind of wanted to show you that. In a La Nina phase, usually in a La Nina weather pattern, usually the polar vortex begins to get stronger. So in a weak polar vortex, a lot of times that cold air can come into the U.S., but that depends on a lot of factors. And a lot of times, sometimes that does not happen in a weak polar vortex, but there's more of a potential with it in a weak polar vortex for that to happen. Okay, so now we're heading into a strong polar vortex. Now, in the strong polar vortex, let's see here. Strong polar vortex, below average geopotential heights associated with a strong polar vortex, as you can see here with these purples. A pattern of lower than normal atmospheric pressure over the Arctic leads to a strong westerly winds in the upper atmosphere in the northern latitudes. So as low pressure strengthens here at the poles, which is where the Azores high usually is, the low pressure system is stronger than the Azores high in the weak polar vortex. Then the strong polar vortex, the low pressure strengthens, which the low pressure is stronger than the Azores high, and strong westerlies keep the cold air out of the United States usually. So, and out of Europe as well. Europe stays warm also. But usually that's what happens. But I want to kind of bring you in on something. In a La Nina weather phase pattern, this strong polar vortex, depending on what position it is and if it doesn't stay locked in place, A lot of times the cold air can come down with a polar vortex also if the belt buckles or if the westerlies begin to weaken and the polar vortex has been getting strong and the westerlies begin to weaken, then the belt of air begins to buckle in the Arctic and allow this cold air to come down into the United States. So if that happens, then we get some very, very, very cold air into the United States. So I just kind of wanted to let everyone know that that would be a rare thing. It's kind of rare when that happens, but it does happen. It has happened in the past, not too long ago it happened. So that's what happens with a strong polar vortex. So any of these could happen in the La Nina weather phase pattern. And with the strong polar vortex, this here is actually I have two low pressure systems here, but usually it's an Azores high and a low pressure system. But in a strong polar vortex, you could have multiple vortexes developing, which could allow more cold air to come down as well. So in a strong polar vortex, this can happen, and allows very, very, very strong polar air or cold Arctic air to push down the U.S. But this is not typical when a strong polar vortex is in place, because usually there's a warming pattern, and there's usually this doesn't happen. But in a rare pattern, this does happen, and temperatures get a lot colder a lot of times than they do, or can get a lot colder than in a weak polar vortex. So, for the La Nina neutral phase or neutral phase pattern for snowfall predictions, this is what I'm predicting, everyone. Now, this could go wrong, but this is what I'm predicting. Below average snowfall here for the Gulf Coast and the southern states, average north of that here into Oklahoma and into the two areas of Eastern Carolina, into the Eastern Carolinas. But I think with this La Nina weather phase pattern, I think that if the westerlies weaken, more cold air could be allowed to enter into the United States. Now, if the polar vortex gets stronger and then something happens to cause the westerlies to weaken, then cold air could be ushered in, and cold air could dip all the way down to the south, and low pressure systems can develop along that. And because of that, right here, I think that this will be the bullseye for snow and heavy snow and major winter storms here around the Great Lakes regions, here in the Northeast and the Mid-Atlantic states. As storms develop here from Florida and move up the coast and become nor'easters, or they come out of the northern states and are very strong as they come out of the northern states and tap into moisture, and then that precipitation becomes snow frequently. And then here in the Pacific Northwest, along the mountains here, the Pacific Northwest could get bullseyes of very heavy snow, and around that a lot more rain than expected. So I have that there to kind of show you that with the rain as well. So we'll just see how this pans out according to how the jet stream is and how the polar vortex is. But as far as what you need to know about winter storms and watches and warnings overview. Winter storm warning is for sleet, snow, or ice expected, so take action. This means, which is the pink area here, by the National Weather Service. This means that confidence is high that a winter storm will produce very heavy snow, sleet, freezing rain, and cause significant impacts. Now, winter storm watch means that conditions are favorable. Well, I say conditions are favorable, but that a winter storm is possible. Confidence is medium that a winter storm could produce heavy snow or freezing rain and cause significant impacts. Winter weather advisory is a little less than that, which is this purple area up here, which means that light amounts of winter precipitation can cause some minor travel difficulties. Now, to go a little bit more into that, a winter storm watch is issued when there is a potential for significant or hazardous winter weather within 48 hours. It does not mean that significant hazardous winter weather will occur. It only means it is possible. Significant hazardous winter weather is defined as a combination of 5 inches or more snow, sleet within a 12-hour period, or 7 inches or more snow, sleet within a 24-hour period, and or enough ice accumulation to cause damage to trees or power lines, and or a life-threatening or damaging combination of snow and or ice accumulation with wind. The snow sleet criteria for a winter storm watch for the 5 westernmost counties, just a potential. This is just an example. Happening or higher 6 inches or more within a 12-hour period, 8 inches or more within a 24-hour period. This is the criteria from the National Weather Service for a winter storm watch, which means that it could happen. It could go into a winter storm warning, but it just certain things have to come together to give you that winter storm warning. Okay, and blizzard warning is when there's reduced visibility 1/4 of a mile or more or less for 3 hours. The longest sustained winds of 35 miles per hour or more. So that's yes, and conditions are